Sometimes in our calculator-heavy teaching world, we miss things like these divisibility tricks that make math a little bit easier as we get down the road. There's times I can think of, especially when we're factoring trinomials, if you're there yet. If not, that's great. And you're trying to figure out, okay, what are all the numbers that go into 30 so I can split this up? That it would be helpful to know quickly, what are all the possible numbers for 30? And you might think, okay, 30, that's a pretty easy one. But what if I toss something up here like 111? What if you wanted to figure out, okay, what's a number that goes into 111 that I can think of? Or maybe it's prime. Maybe there is no other number that goes into it. And when we get to problems like these, it helps to know these divisibility rules for integers. And again, integers are just positive or negative whole numbers. So, I'm not talking about anything like 10 and a half or 10.5. I'm talking about numbers like 30 and 111, 15, 0, -3, all those different things. We'll stick with positives just to make it easy, but it works for negatives too. So this one, hopefully you know, but a number is divisible by 2 if it's an even number, or the last digit is even. So if I want to check if 1098, without actually dividing this, is divisible by 2, well, I can see it ends in an 8, so the answer here would be yes, it is divisible by 2. And again, you can punch that in your calculator if you want to see that, but it's good to just kind of quickly see, okay, that's going to be divisible by 2, and then be able to move on. This one will also be divisible by 2 because it ends in a 6, so that's also an even number. This one ends in a 7, that's not even, so this would not be divisible by 2. Okay, so that would be the pretty easy trick to start here. Nothing crazy. Hopefully you've seen that before. Okay, our next one, this is one that maybe some people miss nowadays in math. I know it's one that I learned back in the day, and I've used it a ton of times in math, kind of going through the math courses I've been. But divisibility by 3 actually has a really nice, easy trick to see if something can be divisible by 3. And the trick is that if the digits add up to something that's divisible by 3, then the whole number is divisible by 3. So let's look at kind of what the implication here is. So first off, you might look at a number like 111 and think that that's prime or it's not divisible by 3. At least I would have if I didn't know this trick. So 111, though, it's kind of cool here. If we were to add up all these digits, so 1 plus 1 plus 1, we get 3. And we know that 3 evenly goes into 3 one time. So the whole number 111 is divisible by 3. So the answer here would be yes. Okay, so if we add up all the digits and it's divisible by 3, then the whole number is. And actually, if you were to divide 111 by 3, you would find that you get 37. So 111 divided by 3 is 37. Okay, next one here. So if we check this one, if we add up the digits, so we've got 1 plus 3 is 4, plus 0 is still 4, plus 9 plus 6, so that's going to be 15. So 9 and 6 is 15. These are 4. So if we add these up, we're going to get 19. 19 is not divisible by 3. 18 is, but 19 is not. So this is going to be a big no. So this is not divisible by 3. If we check this next one, if we add all these guys up here, 2 plus 3 is 5, plus another 3 is 8, plus another 3 is 11, plus another 1 is 12. 12 is divisible by 3, so the answer here would be yes. That big number here, 23,331, is divisible by 3, and I figured that out not by actually having to do all that math, just by adding up all the digits. So the trick for divisibility by 3 is that all the digits have to add up to something that's divisible by 3. Okay, next one's also a pretty cool one. Okay, this is divisibility by 4. So if you're wondering if something's divisible by 4, all you have to check is that the last 2 digits are divisible by 4. Okay, so to see if this goes in evenly by 4, we only have to check the last 2 numbers. So if I look at, for example, 24 here, 4 goes into 24 6 times evenly, then this whole number is divisible by 4. And there's a reason for that, dealing with multiples of 100 are divisible by 4, but I won't get into that in this video. So that would be yes. Now if we check this next one, well, maybe we don't know 96, but instead of having to do this, instead of having to divide this whole thing by 4, I really only have to check the last 2 digits to see if 4 goes into it. So if you don't know that 4 goes into 96, we'll check it now. So 4 goes into 9 2 times, that'll be 8. We subtract the 9, we get 1. And if I bring down the 6, that does go in evenly 24 times. And So a lot of you probably did know that 4 does go into 96. So this would also be a yes. If we check this last one here, we can tell that 27 is not divisible by 4. So this whole number will also not be divisible by 4. Okay? 5 has one that hopefully you're also familiar with, pretty easy one, kind of like the even and the odd one, or sorry, the even numbers for 2. If the number ends in a 0 or a 5, so if it ends in a 0 or a 5, it's divisible by 5. So if we look at this first one, whoops, that one ends in a 5, so this would, yes, it would be divisible by 5. This one here ends in a 1, not divisible by 5. This one here ends in a 0, yes, it is divisible by 5. So that's a really easy way to tell if a number is divisible by 5. Okay? Now, 6, it's not too much trickier than the 2 or the 3 rule. Actually, if a number is divisible by 2 and 3, so it's got to be both, if it's divisible by 2 and 3, then the whole number is divisible by 6. So if we know that the divisibility rule by 2, meaning it's an even number, so that first one should check out, we know that it's even. Let's check also that it's divisible by 3, meaning that all the numbers have to add up to something divisible by 3. So 1 plus 0 plus 9 plus 8, that's equal to 18. That's also divisible by 3. So since the divisibility for 2 rule checks out and the divisibility rule for 3 checks out, this whole number is divisible by 6. Now let's check the next one. Okay, so again, we need to check that it's both divisible by 2 and divisible by 3. If it is, then it will be divisible by 6. So if we check the first rule, it does end in an even number, so that is divisible by 2. So it is divisible by 2. Let's just check that it's divisible by 3 here as well. Now, to see that it's divisible by 3, we just got to add up all the digits. Okay, and we did this in a previous example, but just in case you missed it, here it is again. That's 4 plus 15, which is 19. That is not divisible by 3. So this does not divide by 3, so this is not divisible by 6. It needs to work for both, not just one. Okay, next one. So we can see that it's even, so the divisibility by 2 rule checks out. We just need to check that it's divisible by 3 as well to make sure it's divisible by 6. And if we add up all these digits, we got 1 plus 1 plus 1 plus 1 plus 2. That's going to be 4 plus 2, which is 6. 6 is divisible by 3, so that means the divisibility rule for 3 checks out. So since both of these work, this is divisible by 6. Okay, so an easy way to check if something's divisible by 6. I know it looks like a lot of work, but you start doing all that in your head, it gets pretty quick. Okay, divisibility by 9 works a whole lot like divisibility by 3, except now instead of adding things up and having them be divisible by 3, we need them to be divisible by 9. So in this case, if we add up the digits again, I know we've done this one a few times, but we'll do it one more time here for effect. If I add all those digits up, I get 18. 18 is divisible by 9, so that whole number, this whole thing, is divisible by 9, so this would be a yes. Okay, again, we've added this one up a few times. I've added up all these digits and I got 19. 19 is not divisible by 9, so this would be a no. Okay, if you want to check those numbers that they add up to 19 again, you can. Let's check 342, again, a number that you might think maybe it is, maybe it isn't. If we add these up, 3 plus 4 plus 2, that's going to give me 7 plus 2, which is 9. 9 is also divisible by 9, so that's going to be yes, that whole number will be divisible by 9. Okay, we've got one more to teach you. This one's the easiest one of all. And a number is divisible by 10 if it ends in a 0. So if a number ends in a 0, it's divisible by 10. So this is 200 is divisible by, I can't talk, divisible by 10. 135 is not divisible by 10 because it doesn't end in a 0. This one again, 67,890, that whole thing is divisible by 10 because it ends in a 0. So on the next slide here, I'm just going to give you a quick summary of all the different things I talked about. If you want to take a picture of that or if you want to jot some notes down, those are all the divisibility rules kind of summarized. Just remember, if it's divisible by 2, it has to be an even number or end in an even number. If it's divisible by 3, all the numbers have to add up to something divisible by 3. So an example would be maybe 1, 2, and then let's go with 3. So 123 would be divisible by 3 because those all add up to 6. So again, you can go through, look back at some of the examples I did, but those are all the different possibilities. I'm sorry, there are other rules out there that are that help you with divisibility, but this is going to be one, probably some of the simpler ones. There's one for 8. I can't think of a good one for 7, but if you go online and you look up some other divisibility rules, there are some other cool tricks out there too.